All right. Hello, everybody. Thank you for joining the Cleantech Showcase. That is uh, a joint event run by GC Ventures and Deep Tech Showcase. There we go. So for today's agenda, we will have some opening remarks, a bit of a discussion on funding opportunities, and then we'll dive into some pitching sessions with some startups that we have here to present. Just to talk a bit about Deep Tech Showcase, our sorry, our vision is to bring deep tech to market by leveraging the power of the community. This community consists of startups, tech scouts from the government and corporations, as well as investors looking for deal flow. And we anchor our ecosystem with monthly showcase events by industry theme. So this event happens to have a clean tech theme, but we have other themes like space, computing, um, advanced materials, energy, aerospace, defense, and so on and so forth. And at these events, startups pitch to a panel and audience of tech scouts from the government, major corporations, and to investors. Between our events, we have stakeholders like investors, corporations, and government folks who turn to us to scout specific technologies that they're interested in. So we send over some company profiles that are germane to their interests for them to review. And when there's mutual interest, we make a warm introduction and business often follows. Just a quick plug of some of our upcoming pitch events. So as I mentioned, we have a Future of Computing showcase that is actually later this month in about 2 weeks, November 20th. And then we have an aerospace and defense showcase that is set for January 29th of the new year. We hope to have you join those as well. Here are the companies who are going to be pitching throughout the day. So we have B-Base, Creative Power Solutions USA, Loop CO2, and BetterG Corp. And then we also have Rocky Tech, Arctura, Molecular Rebar Design, and GDI. Just a very quick word from our sponsor, Equal Point Funding, which is the company behind Deep Tech Showcase. They help companies, startups with federal funding opportunities, finding different research grants and contract opportunities for the companies, and helping companies write the story of their tech in a concise, clear, compelling manner. I highly recommend you reach out to my colleague there, David Fertig, an account executive, and I'll post his contact info in there if you'd like to learn more. And with that, I'll hand things over to Lisa and Carol, and they could take it away from there.
All right. Thank you, Brian. So first of all, I want to thank Brian again for and Deep Tech Showcase for letting me co-host yet another event. We did the same thing last year, and it was super valuable and fun. I've been a panelist here on the showcase for many sessions, and both as a panelist as an investor, I find them, really valuable. So again, we showed the agenda here, but we will have two speakers today talking about funding opportunities, Jerry Hollister and Andrew Bray, and I'll introduce them in a couple of minutes. And then I think Brian already went through the pitch sessions. So just a little intro. I am with the Boston-based corporate venture arm of PTT GC, or GC for short. So I'm with GC Ventures. And we're a Thailand-based petrochemical company and the largest polyolefin producer in Southeast Asia. And we are part of PTT Group, which is the national oil and gas company of Thailand. And beyond our Boston CVC team, we've got a CVC team in Europe and in Thailand as well. And so, as I just described, this is who we are. We tend to invest in a couple of key areas around advanced materials, biotech and life science, and clean tech. And Carol, if you go to the next page, we can elaborate a little bit more on that. And so these are sort of the core areas where we either invest in or we facilitate collaborations with startups and other companies both with GC and some of our wholly owned subsidiaries. So we look at areas like coatings and catalysis and chemistry, industrial, biotech, bioplastics and composites, bio-based chemicals, green chemicals, big focus for us now. I mean, in the clean tech space, CCUS, plastics recycling, and a few other areas. And on the digital platform, maybe more around collaborations and actual investments. I don't want to take up too much time because I know that we're all really here for the discussion on funding and also to hear the pitches. But I would like to introduce Carol Radke. She's with DOE's Partner Pitch Program, and she's going to give you a little bit of insight into her program. And then after she speaks, I will introduce our funding speakers. So, Carol?
All right, now that I'm unmuted. Okay, thank you very much, Lisa. And also, I would like to extend a thank you to GC Ventures and to Cleantech Showcase for enabling us to showcase some of the companies that participated in our virtual partner pitch program the last 2 years. Again, my name is Carol Rabke. I'm a tech to market advisor focused on partnering within the Office of SBIR and STTR programs at DOE. So just quickly, why are partners needed? They're needed because commercialization is a statutory goal of the SBIR and STTR programs. So Congress devotes about $4.4 billion a year to this program, but they want to see return on investment of the taxpayer dollars, so taxable revenues, job creation, scientific or societal benefit. And to get there, SBIR funding will only get them so far. So we launched in January of 2023 the Virtual Partner Pitch Program that provides an opportunity for these DOE-funded SBIR and STTR Phase 2 technologies to be pitched to potential strategic partners or investors. 130 plus, I think it's about 139 have pitched to date. And you're going to see a subset of those. You are going to see 8 companies that were selected by GC Ventures and Cleantech Showcase to pitch today. And all of the 130, if you're interested, their pitch recordings are available on the SBIR partnering platform. The benefits of partnering with a small business that has SBIR and STTR funding is that they've received over $1 million in non-dilutive funding to develop this technology. The majority are at TRL 5 to TRL 7. They are all cutting edge, advanced technologies. Many are disruptive. They are technologies that can drive your net zero and sustainability goals. They provide immediate competitive advantage. If you're looking within DoD, they are also Phase 3 eligible, and they are vetted. They all went through a competitive award process. I think that is our last slide, so I will stop sharing and turn it over to Jerry. So I don't know, Jerry, if you want to upload your slides while Lisa introduces you.
Yeah, so Carol's program is also great, and I would encourage any investor here on the call to really look into it. I've met some great companies that way. So next, we have Jerry Hollister, who is with BBC Entrepreneurial Training and Consulting. He joined the company in late 2017, and he became co-owner of the company in October of 2023. Today, he leads strategic partnerships and customer development efforts. He currently serves as a reviewer for NSF, DOE, USDA, and NOAA, and he regularly speaks about SBIR, STTR at national and regional conferences. He also worked at a startup called NiaWave, and he led a team that received, get this, 45 SBIR, STTR awards worth over 20 million. So that's pretty impressive. So Jerry knows your pain. He's an even more impressive background than just that. So let's welcome Jerry, who will talk to you about a range of funding opportunities.
All right, thank you. Sorry, I've got a cold that I picked up at a conference last week, but it's great to be here with you. Thank you for the invitation, and thank you to the sponsors. I got to just run through this really quickly. We're just going to talk about a number of federally funded innovation programs. And so that as you pursue these, Carol already talked about SBIR. I will mention that, but that's a little bit more about my history. Innovation, as Carol already said, I don't really need to redefine it. It's pushing forward the state of the art, new technologies that are enabling new products and services. That's really what the federally funded R&D projects or programs are looking to fund, is innovation. The challenge is, and the venture groups like Lisa's group here, they want to see that it's past feasibility. The venture groups are not going to invest early stage, and so they want to see that that there's a viable product that's where's my pointer here? That an MVP, you're past TRL 6, 7, somewhere in that range. That's what they're going to want. But the inventor themselves, they need funding to get to that point because they've got this basic research they need to convert into a usable product. And so you get into this chicken and egg or eagle and egg situation. And that's where these funding mechanisms come in, is they're designed to bridge that gap, where the federal government will come in. They'll be that early stage, SBIR calls itself the seed fund, early stage funding mechanism that will bridge that gap, get it from basic idea to a usable, well, at least an MVP. And so that's the goal of all these programs. Now there's a number of them. I'm just going to skip through them really quickly. SBIR, STTR, Carol already talked about it. By the way, a lot of the success that we had at Niway was because Carol taught me so much back in the day, 20 years ago almost now. So I'm glad to be with her again. But SBIR, STTR, big program, 3 phases to the program. First phase is feasibility. Second stage is where you prove feasibility in phase 1. Then in phase 2, the idea is that you get to the point of an MVP. And then phase 3 is where the company is selling their product or service commercially. Let's talk about some of these other programs. The Technology Commercialization Fund, I believe we're going to hear more about that here in just a second, so I won't say a lot about it, but these live links will take you to the information for each one of these. This is a prize program. They have specific topical areas that you'd want to make sure that your technology aligns with. The American-made challenges also coming through the Department of Energy. These come out of NREL. These are, again, prize awards. They tend to be smaller amounts at the American-made, and they have several topics every year. So if you're more earlier stage and just getting started, then the American-made challenges could be a good place for you as well. ARPA-E, also out of the Department of Energy. They have 2 kind of levels of funding. They have regular topics, which are open to both large business and small business. They have various funding levels for the different topics. And then because it's so big and the SBIR kicks in, they also have SBIR topics. And so those are only open to small businesses, and they match the funding level of the DOE's SBIR program. So that's 200,000 and 1.1 million for phase 2. Phase 1, 200,000. ARPA-H is similar to ARPA-E, only it's run by the Health and Human Services Department. Again, they have regular topics that are open to small and large businesses. And again, they have various funding levels depending on whatever that topic is. And again, they have SBIR topics, which again, only open to small businesses, and they match the funding levels. There's several long-range broad agency announcements. Several agencies have these. These are DOD is a big one, Homeland Security, DHS, and then NASA. Basically, these are wide open topical areas. They have limited amount of funding attached to them. So what they're usually used for is to try to get a start to a program and then transition. They get some early stage money into from this long range. It's basically an open topical area. Now, these are also open to large businesses, so this is not a small business set aside like some of these other programs. So if you got any interest in those, you'd want to make sure to connect with whoever's running that long-range BAA. BARDA, CDMRP, and the what used to be called the RIF at DoD, Rapid Integrated Scalable Enterprise. BARDA's out of home Health and Human Services. This is also open to large businesses. CDMRP, Congressionally Directed Medical Research Program, run out of DoD, Department of Army. They have specific topics. They are about half the size of SBIRs, usually about $2 billion a year. So there's real money at CDMRP. Those are also open to large businesses. And then the RIP, well, it's called RISE now. They have the Office of Small Business Programs at DoD has specific topics, and those are small business set aside. And the links to all those different programs are there. Continuum of Capital, SBIR, and some of these other programs are, they're pretty early stage. You're wanting to get some of these programs funding your early stage development so that then you're eligible where the venture capital starts to get interested in you. You're past MVP, you're starting to have a saleable product. That's when you're investable. Apex Accelerators, I just put this up there. They are co-funded, and then the SBDC's 2 resources available to you. And this is just kind of shows kind of the tree of all the different, every leaf has got a different funding mechanism, and some of them are only open up to small businesses, some are open to large and small, and some are not R&D. We didn't talk about those because you're all the innovation people. But that's it. I don't think we have time for questions. I will now hand it back over to Lisa. Thank you.
Right, Jerry. Boy, that was a lot of funding opportunity right there in 10 minutes.
Yeah.
Well done. I hope folks had a chance to do some screenshots there. So next up, we're going to hear from Andrew Bray. He's with the Department of Energy's Office of Clean Energy Demonstration, where he's responsible for strategy and program development. And prior to that, he was a senior consultant at Aurora Energy Research, as well as being a principal and partner at MXV Ventures. So Andrew will take us through some DOE-specific funding opportunities, and get your screenshots ready for this as well. Thanks, Andrew.
All right, can you hear me and see my screen? Great, thanks. And thanks for that breakdown, Jerry. I think that's a good wide encompassing. I'll just touch on a little bit more OSED focus, introduce you to the office, and then a little bit more specifically some of the programs I'm focused on and the funding opportunities involved there, really focused on commercialization. So Office of Clean Energy Demonstrations is a couple years old, really focused on demonstration projects. So a few key words here in our mission statement. Demonstration projects at scale and with the private sector, focused on deployment, market adoption, and equitable transition. So really thinking about, as technologies grow, what more needs to happen beyond simply the technical development, all these other factors, and bringing private industry along. So that's all the stuff that we're thinking about. This is where it fits in. Right in the middle, we have some of the earlier applied offices, ARPA-E, SBAR, earlier than us, and then LPO with the Loans Program Office, a little bit later stage. So we're trying to bridge that divide, fill in that valley of death, and create that continuum. We have a few different provisional technology areas. I think that's just important to keep in mind as you're looking at different funding opportunities, just to see what bucket you fit in. These are all cutting edge, next generation entire industries that we're trying to lift off. So nuclear, carbon management, distributed energy systems, long duration energy storage, hydrogen hubs, and then 2 place-based ones, rural and remote, and then former mine lands. And then all the way at the bottom right is where our programs sit. They're what we call the liftoff enabling programs. So programs that tackle things that need to happen for industry liftoff beyond simply putting projects in the ground. And this is kind of our version of the TCF funding. So these are primarily funded by the Technology Commercialization Fund, and directed towards commercialization, innovation, industry adoption. These are where our projects are located, so really across most all the states and growing. And then real quick, so with these big demo projects, we do have our OSET exchange page. So if there would be any teams, I mean, these are multi-million-dollar demonstration projects, later stage, that's where you would go. Other offices as well, EERE has their own exchange page, so do keep those in mind as a source. But I'm going to jump to the liftoff enabling programs that I'm supporting. Kind of talked about the background with the TCF, Technology Commercialization Fund, source of funding. And we work very closely with OTT, so they have a lot of great resources in all of this on this specific set aside, and we work very closely with the other offices as well, but really focused on adoption readiness level as much as technology readiness level. So kind of that entire holistic, what needs to happen for the teams and companies as a whole and supporting those endeavors. We do this through a few different mechanisms. One, financial assistance. Those are your typical grants, often used for the big demonstration projects. I'm going to kind of gloss over that. But the next one is these prizes that Jerry mentioned. This is a big one for our team in particular, and they're growing in size. So right now we have one focused on manufacturing. It has $30 million available, $5 million for the winning team. So more and more that American-made network is focused on getting what happens next with these teams' trajectories. So do keep those in mind. They're a great way to reward work done. And really the idea is make the administrative burden a lot easier for teams to get money out the door. And then the other mechanism is other transactions. And specifically, I'm going to jump to the voucher program that we have that we do this with. So this is run through Energy Works. They act as an intermediary, and the setup is that providers are paid to provide their services for free to recipients. And so we providers apply to become providers, recipients apply with specific requests on modeling, engineering, permitting and siting, a whole marketplace of value-added solutions being made available here. We match them up, and there are then specific projects built around those that teams can get services for. So some examples of descriptions of these services: some focused on pre-demo commercialization support, performance validation, modeling and certification, permitting and siting, and then manufacturing and then industrial decarb. So do check out Energy Works site for what's available for specific discrete pieces of services that you can get, and those are ongoing, open on an ongoing basis, and a great resource. Then just kind of jumping back to the Make It Prize. So support in a few different of our technology areas. This is really helping get that initial planning to the point that you're ready to build, and really helping get that money out the door and a lot easier. So a few teams currently in process there, and future opportunities hopefully to come. Yeah, and jumping back, I'll just kind of mention the full suite of programs we do have. I talked about the prizes and the vouchers, but along with the national labs, we do have a few other more industry collaboration activities focused on MRV work, hydrogen, and long duration energy storage. So do check out our page if anyone's in those fields. We're really trying to make sure that those endeavors are external and industry focused. So that means there's a lot of partners involved with those national lab projects, and it's a great opportunity to just connect and drive those industries forward. And I'll leave with our contacts information. So thank you.
All right. Well, lots of information there. Thank you, Andrew and Jerry, for the presentations. And at this point, I think we are right on time, and I'll hand it back over to Brian to start the pitching. Brian?
Awesome. Thank you. I'd like to thank you as well, Andrew and Jerry. It was great presentations. I recommend maybe leaving your contact info on the chat as well, if people want to get in touch. And everybody watching, I will send out a recording of this. So if you didn't get a chance to screenshot or catch everything that was on the presentation, you could look at it in more detail in the recording. So with that, we will move on to our pitch portion of the event. And what we'll do is we'll start out with a brief introduction of some of the panelists that we have with us. We're still a little early, so they didn't all join yet. But that's no problem. I'll have Hanko maybe introduce yourself briefly.
Sure. My name is Han Ko. I am the founder and CEO of a company called Recycle Group. We're an investment firm. What's unique about our company is that we have a footprint in not just US, but all the way to Asia, and we're pretty much as active in European companies as well. So our interest area is from AI to fintech and software development, Medicare, and along with the other industries. So nice to meet you, and good luck to those presenting today. Thank you.
Great. Thank you so much for joining. As always, Han, it's a pleasure. And with that, we'll have Julia Davery introduce herself.
Hi, thank you. Yeah, I'm Julia. I'm one of the co-founders and general partners at Convergent Ventures. We're a US-based, so San Francisco, New York, and Boston venture capital firm, investing at the seed and Series A level in companies that are addressing issues for people health and planet health. So health and sustainability, in other words. And within that, we look for companies that are commercializing, step change scientific innovations. So I look forward to the pitches. Thank you.
Great. Really happy to have you with us today. Up next, we have Mark Vreek.
I'm Mark Vreka, the current president of the Chemical Angel Network. Chemical Angels, it's an angel network like any other group of accredited investors. What sets us apart is a focus on the 3 M's: materials, measurement, manufacturing. And Cleantech is enabled by basically the materials, measurement, and manufacturing space. So we're here looking for new deals to invest in.
Awesome. Thank you so much for joining us today. Up next, we have Javier Gomez.
Thanks, Brian. Happy to be here. My name is Javier, and I am part of the Defense Innovation Unit team that helps to identify companies that might make sense for future DIU programming. Thanks for having me.
Great. Thanks so much for joining. So because we're at the earlier part of the pitch session, I don't think that all of the panelists joined yet. So to avoid any awkward pauses, what we'll probably do is just get started earlier in the pitches, and then as more panelists join, we'll have them introduce themselves as they ask questions. So we're just going to get started with VBase and their pitch. And we have Jeff and Michelle here to present. So whenever you're ready, you could share your screen. And yeah, looking forward.
All right, you can see the screen and hear me?
Yep.
Can.
Great. I like the little bit of less stress of just a little bit of extra time. 5 minutes is a little bit scary. Well, thank you very much for having me today. Again, my name is Jeff DeMayo. I'm the CEO and founder of the VBase Oil Company. We are a spin out of Tetramer Technologies. So Tetramer is an advanced materials company that brings materials out of the lab into the marketplace. It's been around for 20 years, 25 chemist, material scientist. The work that VBase did was funded in part by SBIR, USDA, and DOE funding as well. So we supply high-performance, environmentally friendly base oils to the lubricants industry. And in doing so, we're addressing global sustainability concerns really across all industries at the root by addressing efficiency in equipment, reduction of materials consumption with longer lasting oils and longer lasting equipment. And then we're doing this in a footprint that is safe for the environment and safe for people. And that's what's really driving this company. So about 7 years ago, we were looking at the lubricant industry and we were kind of seeing some changes in the industry, which is there's a bigger push going towards quantifying and then creating value for energy savings. And there's this push for reduced maintenance where customers are looking for higher value, higher cost in exchange for greater savings. But in addition to that, electric vehicles are coming out, wind turbines, new types of refrigerants, and that's creating new requirements for the lubricants. And so the entire industry is looking at reformulating all their lubricants. And on top of that, we're going to put new government regulations that take away a lot of the additives and manufacturing materials they use while putting on new requirements. So this whole formulation is going about with less ingredients available. And the problem that we are addressing is the current base oils really cannot meet the requirements that the lubricant manufacturers need. So again, base oils are the main ingredient in all lubricants. VBase sells base oils to lubricant manufacturers. So when you think about a lubricant and a hydraulic fluid, a gear oil, a grease, 90% of that is going to be the base oil. And the other 10, 15% are additives. And the difference between a hydraulic fluid and a automotive transmission fluid is the additives. So when a customer uses our base oils, they're getting lower costs to the end user through longer life, higher efficiency, they're getting better performance. And that's what is driving decision making, but they're getting it in a sustainable footprint. So carbon neutrality, environmentally friendly, non-toxic. So we're selling into this $166 billion lubricant market. But we are selling ingredients into the lubricant market. So the base oils market is a $30 billion market, 2028. That includes petroleum coming out of the ground and also synthetic alternatives. If you look at synthetic esters, which we would be classified as, It's about a $4.75 billion market. And we're projecting by 2029, we can be at about 80 million, which is a 1.7% share of the market. Now, that number comes up from a bottom-up number of our top 15 customers that we're talking to right now. Now, in 5 minutes, I'm not going through the chemistry, but I think it's important to show we have IP on this molecule. So this molecule lasts longer, it resists water, it has better performance, and we have intellectual property that we can identify and it's protected. So in order to scale this, lubricants are a global business. And so in order to do that, we have to be able to scale the business globally. So we're looking at an asset-light B2B sales model. We use distributors to sell our products. 11 different base oils that are being sold right now to lubricant manufacturers. We're doing third-party manufacturing. So one of our keys to our business is this is pretty straightforward chemistry. I don't need to build a plant. We already have tote or truck quantity manufacturing, and we can disperse this throughout geographic regions to enable resiliency and also help with logistics. To go to market, we're using stocking distributors, and right now we have a North American distributor with 14 sales personnel that are out there selling the product. We have a letter of intent for Europe and the UK with one of the largest distributors. And then we sell direct to enterprise customers. We are in kind of that transition from pre-revenue to revenue generation. We have had some sales, but our biggest challenge is our lubricant customers have to develop their product. So right now in the industrial lubricants market, which is our beachhead, we have 55 companies that are actually developing new products, testing those products. Automotive lubricants, 5 companies are working in that space. That's including crankcase, automatic transmission fluids. And then we do have some other higher value applications that we're working with a few customers in advanced materials and cosmetics. So we've been able to do this with just a really good team that's been together a long time. I'll highlight Martin Greaves as our CTO. He's based out of Switzerland. He's been with us for 3 years. His 25 years at Dow Chemical, and his role was to bring new base oils to market. That's what he does. Michelle DeMayo's on the call as my wife, also our chief marketing officer, 15 years in technical marketing. And then Zach Bergman have been working in this space for 15 years. I will highlight Ben's background in regulatory and environmental health. Ben and Zach have been able to get us through all of the regulatory processes for North America. So we have full approval for sale with the EPA, with Canada. And in the first quarter, we'll have EU and UK REACH approval as well. And then we have an advisor, Dan Murad, who's very experienced on the exit side, preparing us for exit. So we're closing right now a $2 million seed round on a $9 million pre-money. 60% of that's committed. We do have our lead. And we're using that money to accelerate sales by increasing our sales cycle, increase revenue, and increase our global market by going through regulatory compliance. We have a $650,000 DOE grant that was awarded September to look at high efficiency hydraulics, quantifying that, as well as a $2 million grant we just put in that we look forward to getting. Our exit plan is to look at an exit in 2029 once we've established global regulatory, global traction, and we'll be at a point where you'd be at an inflection point to consider bringing manufacturing in-house. So with that, I'd be happy to take any questions you might have.
Great. Opening the floor up to questions. So if anybody has a question.
I have one question. Actually, great presentation. You have a great product, actually. How would you compare your product to your lifespan of your product compared to other lubrication, also like energy efficiency, perspective?
Sure. So one of our challenges is, and we don't have this in our 5-minute pitch, we're entering the market kind of pricing it as a competitive pricing, and we'll move to value pricing over time as we've been able to demonstrate the value proposition. We're looking at lifetimes 20 to 60% longer than synthetic esters, but base oils have to be formulated to be fully tested out. And until we get those, put them in the market and get real world life cycle analysis, it's going to be really hard for us to make claims around those products. So we're expecting the 50 to 100% increase a lifetime. The efficiencies is even more difficult because that is really dependent on getting third-party data. The DOE funding we have right now is actually going to give us that, but we're expecting between a 10 to 15% increase in fuel efficiency.
Oh, great. Thank you. Are you working with any global companies right now? The customer includes,
Yes. Yes.
I mean, based out of USA.
So we are selling we are selling and working with companies every continent except for Antarctica. So we can sell product and do sampling and product development on any continent. We just can't sell commercial product outside the US right now. But we are teeing up with a lot of customers in Europe right now as well to get prepared for reach so that they can sell once we have reach.
Gotcha. If you need any overseas introduction, let me know. We can chat later. Thank you.
Okay, that'd be great.
Jeff, I have a question. Another angle about the margins, because you said on one hand you're doing with no capex, and you have third-party manufacturing, but and you're working through distributors. Isn't all that, besides the fact that when you get to value market, isn't that eating up all your margins in this kind of business? Because I assume there's quite a bit of competition, and like when do you expect to get to profitability with all these the issue that was asked before and what I'm asking you now?
Sure. So I think an important piece is from a contribution margin perspective, we can sell the oil profitably at a drum scale. So we don't have to get to large scale to sell product. So to break even with our R&D background, G&A, where we have a lack of revenue, that that will take us, we expect to be there in about 18 to 24 months. Our strategy though is we're still projecting 20% net margins, or yeah, depending on our background there. But our goal is to grow revenue quickly. We're less concerned about margin right now because I can always bring in sales in house. And that's kind of our inflection point at 5 years, is when we have 3 to 5 8,000 gallon reactors going across the globe. We can bring those in house and then capture the value chain, upstream and downstream. But really, what's key for us is revenue and volume of oil sold in the next 3 years.
Yeah. Okay.
I have a question.
Mm-hmm.
Regarding revenue. You said you were working with 55 other companies or partners, so they got to certify them. So what is the time span for that?
Sure. Again, things that are in our longer deck. It's an 18 to 30 month sales cycle. That's why we're here today. If it was a faster sales cycle, we would be doing this with less investment. So yeah, between the time that we first sample a customer, they have to take that, run it in the lab, do some formulations, do iterations, and then get it out to market and do some testing. So it's an 18 to 30 month sales cycle is pretty average. Most of our customers we've been working with over 12 months. So there's a range of when we expect products to go to market. Some we expect in Q1 to be on the shelves in Lowe's and Home Depot. Some other larger customers are starting to do field trials, and they expect at the end of the field trials to be in October of next year. And then it's turning into a $300,000 product line for us to start with. And that's our average customer's single product line they're projecting to start around $300,000 a product line and then ramp up, over the next few years to larger volumes.
Yeah, thank you.
All right, that's all the time we have. But thank you so much, Jeff. That was a great presentation.
Great.
And,
thank you.
Please leave your contact info on the chat. Now, before we head over to our next presentation, just because we had a few more panelists join, I'll allow them to introduce themselves very briefly. Maybe who you are, what company you're from, tech you're interested in, etc. So I'll actually start with Muzibul Khan. If you just want to introduce yourself very briefly.
Sorry, you just called me, or I didn't quite catch that.
Oh, no.
No, you didn't, right?
Muzibul from Kyocera.
Okay, sorry. I mean, there was some sound problem, but anyway, I'm sorry for joining late. I was having some problem with the web link. So I am Muzibul Khan. I work for Kyocera Corporate R&D, and part of my role in North America is to technology scouting, you may call. And we work with our partner CVC, Kyocera CVC organization, to support emerging startups in the deep tech space. Nice to meet you all. By the way, I'm located in Sunnyvale, California. So if you are in California or visiting California, please give me a call. Love to meet up with you.
Great. It's a pleasure to have you join us. I also see Samuel Kim.
Hi guys, my name is Sam Kim. I have a venture capital fund based in Austin called Gap Ventures. We invest in early stage advanced materials companies. Thank you.
Awesome. Thank you so much for joining us. And I see Robert Evan.
Yeah. Hi. So I'm Robert Evan, the part of the M Ventures team. M Ventures is the corporate venture capital arm of Merck of Germany, or EMD, as it's known in the States. Looking for sustainability investments around semiconductor, electronics areas are more interesting space. Thank you.
Awesome. Really happy to have you join us. So with that, I think that we can move on. If I missed you as a panelist, sorry. Just please send me a message if I did in the Zoom chat. And with that, we'll move on to Creative Power Solutions USA. So whenever you're ready, please share your deck, and looking forward to your pitch.
Thank you, Brian. Can you see my screen?
Yes.
Yes. Okay, so hi everyone. My name's Hassan Sader. I work for Creative Power Solutions. First, I just want to say that if you hear background noise, I'm sorry for that. I am in the lobby of a hospital right now. Nothing serious, just had the delivery of my baby daughter. Anyway, so today I didn't want to miss this opportunity to talk with you about our technology, which centers around ammonia combustion for power generation. This slide is on the problem that we're trying to solve. So if I want to start with saying why this is necessary, or why this ammonia combustion is necessary, or is necessary to have this type of solution, is because the fossil fuels today generates about 137,000 terawatt hour annually of energy, and this is about 75% of the global energy supply. So this is a huge reliance on fossil fuels to supply us with the energy that we need, and with a push to decarbonize the energy sector through cleaner fuels and renewable sources. We are looking at a problem that presents itself because of the intermittency of renewable energy. So this is why energy storage solutions are beneficial at this point. So one option is using batteries for energy storage, but this only solves a small scale and falls short when we're looking at long-term energy storage solutions. The viable option is chemical energy. Is chemical energy storage. So this is where we convert the surplus electricity from renewable sources into a chemical form that we can later on use as an energy carrier. And hydrogen is one of the most promising options. The problem, though, with hydrogen is its, I guess, safety concerns and economic concerns hinder its use as an alternative fuel. And so this is why there was a need for an indirect hydrogen carrier for the safe and efficient storage and transportation of clean carbon neutral energy. So our solution centers around ammonia. The idea behind ammonia is that, as you can see on the right-hand side on the chart, is that if we compare ammonia with hydrogen, we see the electricity cost from ammonia being lower than that of hydrogen, regardless of the source. So whether the hydrogen is or the ammonia is coming from a conventional source, a fossil fuel source, or a renewable source. And that could be attributed to the fact that ammonia is 30 times cheaper to store and 3 times cheaper to transport. The other advantage of ammonia is using its infrastructure that already exists for the agricultural sector and other sectors. And actually, the problem though with ammonia, and that's why it's not been deployed as a solution, is that to burn ammonia, it's a bit problematic because it's less reactive, has lower energy content, and I see someone already asked about NOx emissions. It has a higher propensity for NOx emissions. So our technology, our combustion technology, actually we designed a burner that allows us to minimize emissions and allows for a seamless integration into existing gas turbine engines, and also we have already demonstrated successful high-pressure pilot tests under gas turbine operating conditions. Lastly, for this technology, we have already submitted a provisional patent, and we're working on securing IP. The opportunity that we're looking at here is the microturbine market, which is valued at $1 billion globally, which is also ripe for innovation. The microturbine sector is, less than 1 megawatt engines of capacity less than 1 megawatt, and if we target about 1% of that, we're looking at a $10 million market share. Quickly, we've gained traction in the agricultural sector. We already have someone lined up to demonstrate this engine at their site, at their farm. I also wanted to mention that this microturbine market is only an entry point for our technology. The idea is to have the technology later on be scaled up to the larger gas turbines, where 2,000 gigawatts of installed gas turbine capacity is awaiting a solution like this, a conversion or a retrofit into a cleaner energy source or fuel source. Our strategy here is to license or operate the model or operate the technology by working with manufacturers and OEMs. This will be the first ammonia combustor technology to power microturbines. We have secured $3 million of non-diluted funding from the U.S. Department of Energy through SBIR Phase 1, Phase 2, and Phase 2B programs. We have letters of support that showcases the need for such technology. Showing here the timeline. I'm not going to go through it. Again, there's no technology in industry right now that burns ammonia, and the only one that's been, is set to be released is in 2025 by Mitsubishi, but it targets the 40 megawatt engines. So we're targeting a different class of gas turbines. Our team is very strong. We have extensive industry experience developing technologies for large gas turbines, for power utilities and specialized applications. We have proven leadership, and we have a team that includes senior executives with a solid track record of pioneering and commercializing advanced firing systems. I don't want to go too much on this. Our next slide is on what we're asking. We're seeking to raise $4 million to accelerate this launch of the ammonia gas turbine combustor. These funds will be crucial for accelerating the market launch, expanding our team with top talent in business and technology, and conducting extensive field tests to validate and refine our product. Lastly, I want to thank you for listening in and giving me this opportunity to pitch our project. I look forward to discussing how you can be part of this transformative journey. Thank you.
Great. Thank you so much for the presentation, and huge congratulations to you and your family on the birth.
Thank you.
So opening the floor to questions, you could either just button ask a question, or you could raise your hand on Zoom. And the way you do that is you go to React and for raising hands. If you don't see that React on the bottom, it might be under More, depending on what your Zoom control panel looks like. So it looks like we have two panelists here who managed to figure it out. So we'll start off with Julia.
Hi, Hassan. Thanks for the presentation and congratulations. Does this make sense from an environmental perspective only if you can produce ammonia with renewables as opposed to the Haber-Bosch process? And then in that case, yeah. Oh, sorry, go ahead.
Yeah, thanks for your question and thanks for the congrats. So we're looking at both. So our techno-economic feasibility study looked at both options. From an environmental perspective, it does make sense because currently, I mean, we are using fossil fuels. So with carbon capture as an option during the production of ammonia, it's called, they're calling it blue ammonia in industry, and so yes, it does make sense. In that perspective, it's actually cheaper to do so as well. Electricity cost is cheaper. Thank you.
All right, Muzibal.
No, thank you very much, for interesting presentation. So I have a very fundamental question. A lot of people are talking about how to utilize ammonia as a carrier, energy carrier, which you're also coming up with some concepts. So can you tell me about this microturbine usage? Where are you at the TRL level using your technology with other partners that you have been approaching?
Thank you. Yes, so I can tell you that we don't really have a turbine that we're testing. What we're doing is we're developing a combustion technology that could be implemented in existing gas turbines. And so what we designed for is large scale gas turbines, ones that are used in big power plants. And what we did is we scaled down the design to a small scale gas turbine, in the range of actually the one that we've tested the technology under conditions. The representative of that gas turbine is a 65 kilowatt engine. So it's a small engine which allows us to easily do demonstration tests and do a proof of concept, and so the engine, the micro turbine engine is used in many industries. We're seeing it in the clean tech, in high tech industries, in Google, Amazon, and these companies are willing to pay a premium to become more green. And so this is where we're seeing this kind of one of the angles that we're looking at. Another one would be the agricultural sector where ammonia is already used. So we're talking to a farm in Minnesota, and this is where we're going to be doing our first demonstration test at the farm. So they're going to be using the power from the engine to power their store, and the heat coming from the engine will go to provide heat to the pig farm that they have.
Yeah, I think I agree with the previous commenter about challenges with ammonia. I mean, today already ammonia production is causing a huge greenhouse emission. And unless we figure that out, utilizing ammonia for microturbine or any other cases might add to the injury. So if your solution is to look for the microturbine to utilize ammonia, can you tell me what is your price point that will make sense for the user? Because the user is going to use ammonia to produce electricity. So the electricity cost, how do you see that with the current market?
Very good question. So yeah, I think in one of the slides, I do show, or we do show the electricity cost, and we compare it with the current electricity cost. So using using conventional sources, so using fossil fuels to produce ammonia, the cost of electricity is in the range of current electricity cost. Now the problem is when we go to renewable sources, producing ammonia from renewable sources is 2 or 3 times more costly than current electricity cost. So so that's true. It's true that is a problem. But what our strategy is that by the time we have this technology deployed, this gas turbine solution deployed, we expect that the cost of ammonia production from renewable sources is going to be much more in favor, just because of improvements in technology and production processes.
Thank you.
All right, great. Well, thank you so much, and that's all the time we have.
Thank you.
But
Thanks, everyone.
presentation, questions, and again, congratulations. And feel free to leave your contact info in the chat in case anybody wants to get in touch. And with that, we'll move on to our next presentation, which is Loop CO2. So whenever you're ready, please share your screen.
Yes. Good afternoon. So can you see my screen?
Yes.
Okay, perfect. Yeah. So my name is A1 Wang, CEO of Loop CO2, and I'm not here to introduce you the A1 steak sauce. That's my name, but I'm here to give you the secret sauce of Loop CO2. So what we do, we make affordable and upcyclable plastic from carbon dioxide and biomass feedstock. All right. So the challenge we plan to solve would be there's a sustainability challenge for the plastic industry. Right now, the plastic industry creates more than 1 gigatons of the carbon dioxide every year. And the plastics also make out of so many different types of plastics. So even with the 3 products I show over here, there's more than 10 different types of plastics. And none of those is designed for recyclable. So it makes it really difficult for us to recycle those materials and reuse those resources again and again. Most of them would be just like degraded or like just a landfill or like burn it out. So that's caused a lot of social cost, and also the plastic value would be just a waste. So we come up with a solution. Is one type of the chemical recyclable carbon dioxide polyester. So it's a CO2 based. So we're using the sustainable raw material, only 29% of carbon dioxide and 71% of the biomass material. Then we can turn that into a monomer. And this monomer really interested. It has so many different potentials. It has a reversible functional handler, so that we can start to like connect with the different chemicals and like form a lot of potentials. There's 27 potential like chemicals we can create out of this technology. So right now we focus on our first generation would be a fully hydrogenated monomer. So we can turn that into the polyester, and then let's get into the build up into the existing material. So we connect with the existing ecosystem. And then once the product is manufactured and consumed, in the future, we have a technology to deal with the end of life. So we can use a low temperature to doing the chemical recycling around 100 degrees C compared to all other solutions. Other chemicals require almost 180 to 230 degrees C. So that makes the chemical recyclable affordable as well. So this is a truly the circular economy can be formed. And as I mentioned earlier, we have a long-term goal to build up based on all those possibilities. So we plan in the future to build up the whole plastic family based on this material. So all the material can be kind of doing the chemical recyclable. So based on we talk with Amazon, Amazon give us a very interesting term. They would like us to make something like a chemical soup. Then we can kind of once everything is finished, we just put it back and then like turn back into the original monomer. So the whole system would be like be used again and again. And for our business model, what we will focus is we were doing the monomer production. So we will provide the raw material supplier, and then we connect with the existing ecosystem. So existing supplier, they just get the material from us. Once it's finished, then we will licensing the technology working with waste management company to deal with those like a chemical recycling portion. So that will be our focus on the market. So coming back to our first generation material, we did a lot of testing and then try the different possibility. So we figure out these three like major potentials we can use in the different functions. So from the bioplastic additives, adhesive to TPU, the polyurethane or like a thermoplastic elastomer type of the materials. So each usage we talk with different company through the customer discovery program from DOE, ICORP, and also Phase Ship 2 program. We have talked to more than 80 different companies. So TSMC and also Integris, they are very interested in the chemical recycling portion for the chemical mechanical polishing pad, so which is using in the semiconductor production process. This will be the potential polyurethane application to doing the chemical recycling. On the other hand, we also talk with HB Fuller, Henkel, or BASF. They are very interested in the adhesive portion. 3M is also one of them, because like our material is showing 50% improvement in adhesives, like the peel strength. And the last one would be for the bioplastic additives. Right now, for the most common like compostable material is a PLA, polylactic acid. But this is PLA is really brittle. So there's some challenge over there. We consider this can be part of the additive. So from all the discussion with different companies, we kind of shrink down to our serviceable, like the beachhead market would be for the impact modifier market for the PLA materials, which is around like a $300 million dollars revenue every years, and also it's growing quickly. It's 17.1% the compound growth rate. So what we solve, what will be the problem customer are looking for right now? Because PO is so brittle, the elongation would be only 2 to 10%, and we can kind of extend that to 60%. And as you can see over here, the existing usage, for example, for Starbucks, they have a straw is made by PLA, but it's really brittle. So after certain chewing, it will be break and it cannot be used as straw. same as for the 3D printing filament. So this is the shortest solution customer is looking for. They want something they want a soft composable material, polyester can be used in their application. Because right now, most of the bio-based material is more rigid. So everybody are looking for the soft material, and our material fill the gap. So this is like when we talk with NatureWorks, the PLA manufacturer or HP Fuller, they are really excited to see this. And then we are getting to the like sample order from them for them to start to working on and testing our material by the end of this year or early next year. And this page is showing the
A1, just want to give you for time 1 minute warning.
Sure. Yeah. So over here is our competitive analysis. So for the soft polyesters, like we have a biomass, and we use a biomass material and also low temperature like recycling, and its hydrolysis stability is really good. And our team is for me, I'm more on the business side, and we have Professor Tang for the science portion, and also Jimmy from industry with a lot of different advisor from breakthrough energy to life cycle analysis. And this is showing our timeline. So we are currently is a TRL 3 to 4, and we build up a scale up lab right now, and the plan to like it will be the drop-in solution. So we are talking to the toller, and then like in 26 to 2027, we plan to like start to the pilot plan and also working on the productions. And currently is funded by Department of Energy and seeking for the 3 million seed fund. Yeah, so that's us. So please feel free to let us know if you have any other questions so we can answer.
Great. Thanks for that pitch. So opening the floor to questions. Uzibal.
Thank you for the presentation. Very interesting concept. Could you go back to your slide number 2?
Yes. Slide number.
Yeah, this one. The next one.
Oh, this one?
No. Yes. So if I look at it, you have given a big high-level picture.
Yes.
But your type of monomer,
yes,
how is it different than the regular monomer? Means because you're trying to put it into the same, supply chain.
Okay. Yes. So the monomer we created is new materials. So it was not exist before. So that's why we start to try to doing the testing with the different properties, and then try to identify like the potential usage. So like our CTO, if we would like to talk about the chemical portion, then we can maybe provide more detail for that portion. But pretty much like is a 6 carbon like monomer, and we doing the ring opening and connect with butadiene. So carbon dioxide connect with the butadiene, and then that's form a new type of monomer, which has a very interesting properties based on what we are currently finding. Yes.
The reason why I asked is, first of all, is this monomer more expensive than the regular monomer? That's number one question. Number two is, once you use this monomer to create products like polyester or whatever, how is your recycling? Because if you can answer those in an effective way, I think people will accept your proposition.
Yes.
Otherwise, you will be always in a disadvantage.
Understood. Yeah. So we did doing the TEA study. So like to answer this way, carbon dioxide, right now, for the beverage like carbon dioxide, it would be around 80 cents per kilogram, and then butadiene is around $2 per kilogram. So based on the percentage, the raw material is really cheap. So material is inexpensive. But the challenge will be for the catalyst portion. So like right now, the catalyst we use, we are working on to improve the reclaim. And so like if we can use the catalyst the extend to so many times, then the cost will be dropping down. So that would be the funding we are looking for to help us to doing further like development for the catalyst portion. So if we can get into a certain desire like recycle like times, then it will be like I mean like the price would be comparable with the existing one. Yeah. So on the other hand, for the recycling portion, right now we talk with a lot of different company. So chemical recycling will be for a longer time. Longer term. The reason is, for the post industry material, it would be easier. For example, like a chemical, the CMP pad in the semiconductor business, because that will be within their factory, and then they can return back to us. So that will be the quickest chemical recycling application we can use. And like if we can help them to do that, we have a like so we did some like evaluation. We can save them 100 million every year through the recycling, because right now they just throw those away. Yeah, so it will be the kind of free material, and then we can reuse again. But it has to be using our material. So we need to build up our material first with enough volume, and then we can make the chemical recycling in the future. That's why we talk with when we talk with Amazon, their long-term goal would be chemical recycling, but in the shorter term, PLA would be still the easiest solution, compostable solution. So right now, the customer are looking for something can be compostable with a PLA, and it's soft material. So our material right now is fill the gap. Yeah, so that's why like this will be our picture market, and this will be, it's not too big and it's not too small. So it is like we can sustain the business first, and then like on the longer term, we can using the like a reverse functional handler and to make additional 27 different type of material. So we can kind of enlarge the whole ecosystem afterward. But for now, we will pretty much will be more focused on the soft compostable material polyester to fill the industry's need first.
Thank you. It's a very interesting proposition. Love to hear more from you.
Thank you.
So unfortunately, thank you. Unfortunately, that's all the time we have actually for CO2. But Mark and Han, please maybe I'm sorry for not being able to have you ask your questions live, but please maybe put your questions in the chat, and their team can answer them.
Yeah, I will provide our contact information as well. Yeah, so
yes, and you could also find their contact info, and you could reach out to them if you have any questions. Again, apologies, just we're a little bit behind, and I'm trying to keep this moving forward. So with that, we're going to head over to our next presentation, which is Bettergy or Amogenics. So whenever you're ready, please share your screen.
All right. Good afternoon, everybody. Let me play this one. Okay. So my name is Zong Tan, with Bettergy and director of Bettergy Corporation, a company in New York. And I'm going to straight directly to the topic to save time here. This topic is actually another, I'm going to pitch the technology related to the ammonia, which called the high efficiency green ammonia cracker. This is we think about it as a key link to the carbon neutral fuel. The world is shifting to renewable clean energy, and there's actually a big challenge here. You can see we have a table listed the energy can come from like a compressed air, pumped hydro, battery, and chemical fuels. Those energy carrier or the energy sources have their advantages, also has their disadvantages. And you can see there's storage issues for the battery, transportation economy issues for the compressed air and pumped hydro, and the chemical fuels. Maybe the solution is right now one of the most important energy sources being used in the world. And the issues we are trying to solve is the transportable and economic. Why? Because the fuel, chemical fuels as the energy sources, you can see the fossil fuel, hydrogen, and ammonia one over here. Fossil fuel right now, there's big challenges of carbon emission, and hydrogen is very ideal in terms of the clean and simplicity. However, it has a challenge here, the storage and the transportation, because it's density and also the very easily the emission is intrinsic property of the hydrogen. So high energy density alternative chemical fuels, one of the option is going to be the ammonia. You can see the energy density, carbon neutral, and storage and transportation. Ammonia all falling into uphand compared to the others. And what we are developing at Vantage, we developed under the fund by DOE SBIR, DOE RFIE program. We developed two core technology. One is the catalyst, is the non-precious metal catalyst can crack ammonia into hydrogen at a very low temperature with very high energy efficiency and no cost. And crack ammonia into hydrogen can provide like a on-site hydrogen production for both application. One is for the like a fuel cell vehicle application, like hydrogen station. Another is for the gas turbine, which Hansen just made a very good presentation on the ammonia as the fuel for the gas turbine. Another core technology we developed is the membrane. We combined this ammonia crack catalyst and the membrane reactor. And in this integration system, we can produce pure hydrogen for the fuel cell vehicle application, and separate the hydrogen from nitrogen. And also the high efficient catalyst provide a complete conversion, leave no ammonia residue. So these two technology combined together has advantages over the current technology, or compared to the competitors' technology. You can see that we are developing the membrane is the non-precious metal, the membrane material itself, because traditionally hydrogen separation membrane they're using like a platinum. So all membrane low cost and robust. And the catalyst itself also is non-precious. Traditionally, people using one non-precious is called nickel-based, but it has to crack ammonia at a very high temperature, as high as like 700 and 900. Another is a precious metal catalyst is the ruthenium-based, can crack ammonia like 500, but the catalyst itself is costly. So we are developing the catalyst can crack ammonia at a lower temperature, but it's lower cost, just non-porous catalyst. So these two breakthrough technology we are pitching here right now. This is just the IP protection from the technology derived from our we call it like a portfolio, and the membrane membrane-based patent that we have one patent issued, US patent and another international patent issued, and a catalyst we have another patent issued, and 3 additional US patent are pending right now. Continuation patent utility also filed. As I said, the technology, the project itself supported by the catalyst part is supported by the RFI program and partnered with a University of Buffalo. So those professor group have a very high impact paper published after the patent, of course. And the figure on the left side is just again a comparison, show the advantages of our technology and also show the potential application, the market also here. You can see the ammonia cracker conventional reactor normally at very high temperature, and using our technology catalyst can crack ammonia, let's say the same performance, but at very low temperature. And combined with the membrane reactor can produce high purity hydrogen directly can be used at hydrogen station, refueling station for the fuel cell vehicle. And another market here is the lower temperature called a reformer, using this high efficiency catalyst without membrane, and will provide a blend of gas like hydrogen, ammonia, and nitrogen. This kind of gas is actually will be better fuel for the combustion engine or for the turbine. And the
Jean, just for timing, 30-second warning.
Okay, yeah, we'll be done. The target product, this is just, as I said, we call it ammonia cracking membrane reactor system for the hydrogen refueling station. And there will be ammonia reformer for the boiler and a gas turbine. So we, technology has a roadmap here, and we actually right now have like a technology readiness level go to 6 to 7. And then we are seeking the funding, like 7 million for the purpose of like IP protection, build the team and prototype development, and also scale up the catalyst membrane for the commercialization. And thank you very much for your time. Take a question. Thank you.
Great. Thank you so much for your pitch. We'll to the question. So again, if you have a question, just raise your Zoom hand, or you could just jump in if you still can't find that button. Julia.
Thanks, John. Can you talk a little bit more about your go-to-market? What partners you're talking to, who are you going to be selling to first, and things like that?
The market here is that what we have actually been try to find the funding for a while. So we have pretty much a lot of material information in our data room. And for the market here, we have like a phase, and then the early stage of the market, we actually think about for example, like the a warehouse forklift. They have the hydrogen fuel cell vehicle forklift. They then will build like Amazon, Walmart. They have the warehouse have the fleet forklift, and it will build the hydrogen station for their application. And there will be also a bus hydrogen fuel cell bus fleet. This is the early entry market, and after that, for the hydrogen station, it's going to be like in the East Coast, and like in New York, in Northeast New York, Boston, in that area, there will be a hydrogen station to be built, and in West Coast, there is in California, there is a number of the project is going to build the hydrogen station. After that, there will also have a large scale like a truck and a marine application for the, using ammonia as a fuel. And another market is actually we are also have pretty much a lot of research on this market is the internal combustion engine and gas turbine using mixture gas of hydrogen and ammonia. And in this case, it's, in New York, we have a ongoing project with developing this low temperature ammonia reformer for the industry boiler application. So the market is step by step, and the total market is pretty much big. Yeah.
Great. Last question for Han. Han, you're mute.
Sorry, we couldn't find my mute button quick enough here. So yeah, actually, it's great here. I just wondering, I mean, a lot of questions I had actually was already answered. That's great here. But how would you answer this question? The competitiveness of the ammonium solution, I guess, right? It actually always a risk of having ground level ozone formation, also possible possible material that harmful to respiratory system, things like that, in general. So I've been always wondering about that, and I think that you're the right person to ask. So
ammonia as do you mean the environmental impact of
right, correct, yeah.
Oh, yeah, this is actually a reasonable question. And the thing is that we have been talking with a number of big corporations, they internationally, and many of them in the East Asia or in Australia. They are using natural gas as a source. They have plenty of natural gas, and they want to transport to the market like in East Asia. One product is the ammonia, and at centralized scale production, you produce the ammonia not only economic but also clean, because as Hansen already mentioned, it's going to be blue hydrogen or blue ammonia. And this, I think, is practically is not only economical available, but also I think environmentally acceptable. You can see only one solution, I think, in the future for the really clean energy, maybe a nuclear. Otherwise, many other called renewable energy, even wind, right, solar, they have their sources of the pollution, I would say. So economically and environmentally, this technology is very competitive. Yeah, we do have a very broad and extensive analysis on those technology in terms of the cost, environmental. So I would very much welcome, contact us if you're interested. We can provide any information to you.
Yeah, maybe you can check it offline. Thanks so much. Appreciate it.
Thank you.
All right, great. Thank you so much. So that's all the time we have. I appreciate you taking the time to share your presentation, and that's it for the first session of the event. The first half of the company is pitching. So I'd like to thank all of the panelists and the companies who pitched for the first session, transition to the second. Quite a few of the panelists will sign up for both, so happy to have you still on. But if you only signed up for the first panel, we're not going to get off, so feel free to stay on if you can. So because we're a little bit behind, I'm just going to have the new panelists who joined the second session introduce themselves very briefly. So I'm going to start with Thomas Blum.
Yes, I'm a Cleantech angel based in New York City. I helped form an angel group and we merged into Clean Energy Venture Group. I worked at NYSERDA. I've been doing this about 20 years, and I may have funded about 50 companies, not all clean tech.
Awesome. Really happy to have you with us. Up next, we have Robert Yancey.
Yeah, Bob Yancey. I am the Director of Business Development for Hexcel. Hexcel is a leading supplier of aerospace composite materials.
Awesome. Thank you so much for joining us. Up next, I have Adarsh Saukar.
Hi everyone, my name is Adarsh Saukar and I'm representing Saint-Gobain Nova, the CVC arm of Saint-Gobain. We invest in early stage advanced material technology-based startups and I'm based in the Boston area. Thank you.
Awesome. Thanks for joining us. Really happy to have you with us. Up next, we have Hyundo Kwon.
Hi everyone. Good morning. Good afternoon. My name is Hyundo Kwon. I'm from Honda Accelerate Ventures. We are a CVC arm for Honda Motor. We invest in deep tech and hardware companies who can help Honda to achieve carbon neutrality and zero fatality. Great to meet you.
Great slogan. Happy to have you with us. Up next, we have Lena McDonald.
I'm with Outsiders Fund. We're a VC firm based in New York City. We're relatively generalist, but we like to invest in relatively unsexy, overlooked spaces, and energy tech as a whole tends to fall under that. My background's in engineering, so love to get to dig into the tech. Thanks.
Awesome. Thank you so much for joining us. Happy to have you with us. Up next, we have Liat.
Hi, everyone. Good to meet you. I'm Liat. I'm a partner at Our Crowd. We are an investment platform that invests in various things, but I focus on climate tech. We're 2.3 billion under management and happy to be here. Nice to meet you.
Great. Happy to have you with us. And up next, we have Tom Gammon.
Good afternoon, everyone. Tom Gammon from Booz Allen Hamilton. I support the U.S. Air Force in all of their innovative technology and development across the world. We do a lot of, our innovation group is run by Dr. Hartman, based out of Washington. And essentially we are looking at all different forces, types of renewable energy. Our primary focus at this point is geothermal and hydrogen. However, we also have a number of different facilities that are available that allow us to potentially invest in some of these new technology as they go forward. So we're looking forward to hearing some of these ideas.
Great. Really happy to have you with us. Up next, I see Alana from Autodesk. If you just want to introduce yourself briefly.
Hello, my name is Alana Monkinsavat. I'm a strategic development manager from Autodesk. I work in research, and my primary responsibility is to scout and recruit projects to come into our technology centers and our residency program. My background is in mechanical engineering, so I also advise and consult on manufacturing and engineering projects that come into the centers. Thank you, Bren.
Awesome. Thank you. Thank you so much for joining. Really happy to have you with us. I believe that's it for the panelists who joined for the second session. But if I missed you for some reason, it was an accident, and please just send me a message so that we could get you to introduce yourself a bit later. But in the meantime, we will move on to our next pitch, which is Rocky Tech. So whenever you're ready, please share your screen.
All right, y'all able to see my screen right now?
Yep.
Excellent. Well, my name is Alex Koenigsberg. I'll be presenting for Rocky Tech today and talking about our compatibilizer. So essentially, to jump right into it, plastic's a problem here in the world. I think we all recognize that. And one of the biggest, well, two of the biggest offenders are polyethylene and polypropylene plastics. So think the milk jug is polyethylene, the cap is polypropylene. And the problem here in America is single stream recycling. When it comes time to recycle that milk jug, we screw the cap back on there, throw it in the recycling bin, and we don't think about it again. But when it gets to the recycling center, you either need someone to go and physically unscrew that milk cap and like take it off, or you need some sort of ocular system, which doesn't really work with polyethylene or polypropylene. So that means that landfill or ocean is the destination for these two plastics in 90% of the cases. What we have, though, at Rocky Tech is a compatibilizer called RevLink. And what RevLink does is it essentially makes it so you can take polyethylene and polypropylene, mix them together, and turn it into a brand new plastic that has similar or better mechanical properties to virgin plastic. The way it works is essentially you get 99 parts plastic feedstock. And you take those 99 parts plastic feedstock, you add 1 part RevLink to that, so 99 to 1, and you put it in the extruder. From the extruder, we can either make a resin, a plastic film, something like that, that the OEM or the converter is looking for to actually make a product out of. And when you look at that market strategy from like the high point, we're essentially making the compatibilizer here at our facility. We actually just got really good news the other day, and we're in the middle of processing our first major order for a customer right now. So we're basically taking the compatibilizer we're making here at Rocky Tech. We then can either sell it to a master batcher or a compounder. It's up to them to then source plastic feedstock from a variety of different recycling sources. They put it into their extruder, and they then make a brand new plastic. They sell that to an injection molder who then shapes it and sells it to an OEM. We've done a lot of customer interviews throughout this whole process, getting ready for this point. We've talked to over 80 different people in the compounding industries, master batching, and the two areas that really stuck out was one, when it comes to the contamination. So what that means is we have our batches are majority polyethylene. We can have up to 30% polypropylene in every batch. We call that contamination of polypropylene. Our competitors, and you'll see that in a future slide, they can only do up to 10% polypropylene, which means that when it comes to sourcing plastic feedstock, they're much more limited than we are. We also learned too that yes, we're competing with other compatibilizers, we're competing with plastic recycling, but because virgin plastic is so cheap and so easy to make, price is really the key. So we have to make sure that we're very price conscious. And we're talking to groups like Ampeset and SI Group, and they had great feedback and the ones that told us information like this. When you look at those competition, there's 3 areas I really want to highlight, and they're all highlighted in green. The first is the percentage per batch. So this is what I mentioned before, where it takes 1 part RevLink to 99 parts plastic. Well, our competition, they need 15 and 20% respectively. And that's ExxonMobil, who's obviously the big one in the room, and then Magris, that's a European company that's pretty similar to us in size and scope. When it looks to the cost per 1,000 kilogram batch, because we require less percentage per batch, it requires less of our material, it only takes about $80 to make 1,000 kilograms compared to our competition. That's about 3.5 times that. And then the contamination percentage, this is what I mentioned before, the polypropylene contamination, a batch of polyethylene. Our competition can only do up to 10% polypropylene. So that means they need to sort the plastic much more so when they're actually getting that plastic feedstock to make their own brand new plastic. Our revenue projections are based off the idea of getting 1 new customer every year for the next 4 years. And then on top of that as well, each one of these customers, based on the interviews and based on the way that they source the material and they sell it to their individual customers, we have a certain expectation of growth for them as well. So every year is adding a customer, but also seeing our existing customers grow to the point where we're hitting just about $12 million in revenue by the year 2028. We do have a patent pending on this product. It is global. And we are looking at doing future patents as well on tangentially related products that use similar chemistry as the original compatibilizer. And we're also looking at doing a trademark. And then anytime we deal with a customer, a potential partner, we have them sign an NDA as well as a non-analysis agreement. The team consists of myself doing business development. And then we also have Alice Jin in the call today too. She's our co-founder, our CEO, and the inventor of the product with over 20 years industry experience. And then Tony Tong is a co-founder as well. He does a lot when it comes to commercialization, as far as partnerships, things of that nature. He works at CU Boulder as well as some of our collaborators or professors at CU Boulder as well. Then we have a team of about 6 other employees as well, not listed on this slide. As far as the ask, we are not fundraising at this moment today, right now. We expect to be probably next year. And that's based off this order that we're talking about right now and some of these conversations we're having with these big companies. We expect that we get some bigger orders based on this first one going well. We're going to need to scale very quickly. So not only would we be looking for funding potentially early next year to be doing so, but we'd also be looking for introductions to toll manufacturers who could help us with that scalability, chemical manufacturers, as well as anybody in the master batching, compounding, or just plastic industries who might be interested in learning more about this product or seeing if it could work for their companies or their customers. So again, thank you all very much. I'm Alex Koenigsberg and be happy to take any questions.
Great. Thanks for that great pitch. So if anybody has a question, preferably you would raise your Zoom hand. And the way you do that is you click on the React button. If you don't see React on the bottom control panel, it might be under More. You might have 3 dots and it says More, and then there's a React. And Julia leading by example with the hand raised. So Julia?
I'll do a super quick one, kind of yes or no. Are you able to make materials that are transparent at the end?
I'm sorry, Julia, could you repeat that question?
Are the materials, like the end materials, are they able to be transparent?
They are not transparent right now, but Alice is on the call, and I don't know if she has any information about what could be in the future. But as of right now, I don't believe we have that.
Okay, thanks.
Mark.
Yeah, do you have a financial ask, Alex, other than introductions to compounders?
We don't yet, simply because we need to figure out what our toll manufacturer is going to be able to provide for us and how much we're going to take in-house ourselves. So it's really going to come down to the fact that we have this order we're fulfilling right now, seeing how that goes, because it's the first time we're really doing this beyond lab scale and doing that actually market scale. And if it goes well, then it could be potentially anywhere between as low as $1 million or as high as maybe $4 million we're looking at. But we would have more information in 2025 for that.
Great. And Julia? Okay.
So it's really, really interesting. I feel like I've seen a couple of other startups in the US working on a similar solution. And so I saw that you have a patent pending. Can you hear me correctly? I'm getting some... Yeah, okay.
Yes.
So have you done a freedom to operate analysis?
I do not believe we've done that yet, to my knowledge, but I know we're going after the global patent.
Okay, yeah. It'd be interesting to see how you kind of create a full IP mode to be able to commercialize without too many worries. But very interesting. Thanks.
Yep.
Great. I believe that might be all the time we have. But Alex, thank you so much for your pitch. Please leave your contact info in the chat. People can reach out if they'd like to connect offline or just learn a bit more. And with that, we'll move on to our next pitch, which is Arctura.
Good afternoon, everybody. Can you see the screen all right?
Yes.
Great. I'm Neil Fine, founder and CEO of Arctura. Thanks to inviting me to this event. So we're a small Rhode Island-based technology company that has developed a new way to synthesize nitric acid at the point of use, using just air, water, and electricity. And I'm excited to tell you about our vision. So there's so many problems with the way in which we make and consume nitric acid today. Most nitric acid is centrally produced at roughly 500 plants that are scattered throughout the world. Much of it is shipped to distant locations. It's, of course, a hazardous chemical, very costly to transport and to store. Making and transporting nitric acid emits more than 100 million tons of global warming gases every year. And the supply chain is also sensitive to global geopolitical events like wars and also to pandemics. So at Arctura, we have developed a new process for synthesizing nitric acid using just air, water, and electricity. Being economical at small scale, one value that it offers is the ability to manufacture the chemical at the point of use. And if powered by renewables and or nuclear energy, our process will emit no global warming gases since it's manufactured at the point of use. Transportation costs are eliminated, storage is limited, and safety is increased, while some of the supply chain risks go away. So the conventional process for nitric acid production, as many of you know, starts with the Haber-Bosch process, where ammonia is produced using air and methane under high temperature and pressure, which often relies on natural gas as a heat source. That ammonia is then converted to nitric acid through what's called the Ostwald process, which is also done at high temperature and pressure. In contrast to that, so Arctura's process skips that ammonia step entirely and synthesizes nitric acid at room temperature and pressure. Air is passed through a low temperature plasma reactor, which fixes nitrogen in the form of NO2, which then gets absorbed in water. Several new innovations make this process that's unique to us both efficient and compact. We'll be protecting those innovations with patents, US and PCT patents that are currently under development. So the total annual market size for nitric acid is about $25 billion per year, and it's broken down by segment, like shown here. Most nitric acid actually is captured right at the point of manufacture in order to make ammonium nitrate for fertilizers and explosives. But the remainder is shipped around the world to make chemicals, semiconductors, a host of other products. So we do intend to address all of these markets, but our go-to-market strategy starts by addressing an important beachhead market by building these small distributed nitric acid plants for use by manufacturers that use chemical milling and chemical etching processes, as well as manufacturers of other chemical products. And the second part of our go-to-market strategy is to partner with one or more large system integrators that are established in the ammonium nitrate industry, and they can get us access to the fertilizer and explosives industries. So we're in the process now of negotiating a deal with one company that designs and builds the large chemical plants where nitric acid and other chemicals are currently manufactured. We are a small team of technologists. I handle all the business strategy in addition to project management and product development. Chris and Pascal lead the day-to-day technical activities supported by 2 engineers. We have a 6-member board of scientific advisors. 2 are shown here, and you can read about them and the 4 others on our website. As a team, we've raised over $9 million in funding, most in federal and state grants. We take grant funding to de-risk technologies to commercialize them. We have successfully launched one product using this funding, which is currently generating revenue. So we're looking to raise $2.5 million now in seed capital, and that will support the development and deployment of our first green nitric acid product. Some of those funds will be used to expand both our technical and marketing staff, and would love to discuss it with you and be happy to take your questions.
All right, great. Thanks for that pitch. So opening the floor to questions, if anybody has any. Tom?
Yes, Neil, thanks. So is the real advantage of this the ability to make it on site and not have to ship the nitric acid, or is it being a green zero carbon product if made with renewable energy?
Well, so for the beachhead markets, we have interviewed more than 80 professionals that use nitric acid in those industries I mentioned, chemical milling, and chemical etching for PCBs, et cetera. And we found that the number one value prop that's of interest to them is supply chain de-risking. So building it on or manufacturing the product on site eliminates some of the supply chain risk. Some of them had some problems during the pandemic in sourcing nitric acid, and that pain is fresh. The value prop of decarbonization is a nice to have here in the United States, not a requirement. On the other hand, for the larger marketplace, we believe that we are setting ourselves up to be ready with the technology if and when new regulations force decarbonization on that industry. That's why we're getting so much interest from the larger industries. So that answers your question.
Great. We do have time for one more question if anybody has any.
Well, I'll have a follow-up. There were other products mentioned on your website, something having to do with wind turbines and lifts. So are you guys really plasma experts that you apply to a number of different fields?
Yes.
Is that part of this company, or have you set up separate companies for this?
No, these are all one company. So our foundational technology or platform technology is low temperature plasma physics and chemistry. We applied that technology to do aerodynamic flow control, and we were pitching that to the wind turbine OEMs, and that's how I started the company. That technology failed to get to market for a variety of reasons we can discuss offline, but that is why we set ourselves up as a wind energy technology company. The one product we do have on the market is related to wind turbine protection of wind turbine blades from lightning. That also would not have been able to be invented by anybody other than a team that has experience with low temperature plasma physics.
Great. Well, thank you so much, Neil. It was a
you.
great presentation, but that's all the time we have. So we'll move on to our following presentation, which is molecular rebar design. Whenever you're ready, please share your screen.
What happened? Great. Oh, I can see it on my screen. I can't see it on yours.
Looks like you might need to maximize the window at first to
Yeah,
make
it
it
looks
bigger.
like it. Yeah, I think you're right. Did that work?
Yeah.
Oh, perfect. Okay, well, thank you for the time. I'm here to talk about a bit more mundane subject, which is rubber. And what we have is a rubber additive that we put into only high value markets. If somebody doesn't want to pay 5 to 10% more than for his rubber, we're not very interested And there's a market segment of the $400 billion odd dollars, roughly 1%, where time is everything to customers. So there's actually 4 segments. I'm going to talk about this one, which has a lot impact on the environment. And this has to do with EV tires. We swore up and down we would never do anything with consumer tires, and here we are. And part of it is if you have an EV vehicle, you'll find your tires wear out pretty quickly. I know everybody talks about batteries and they talk about, software, but if you're an actual user, you worry about your tires, which can wear out 20 to 30. Some people can wear them out 50, 60% quicker, and those are expensive tires. The other thing is, another issue is how many times do you have to charge? And what really is needed is a longer lasting, more energy efficient tire for electric vehicles. So what we do is we take carbon nanotubes and they're made in bundles and make the individual tubes. Our tubes are about 14 nanometers in diameter and about 800-900 long. And these individual tubes change properties of many materials, but particularly rubber. And what you can do, you can see the spider diagram. The black is a standard formulation. And if you move one of those variables and make it better, it decreases the other one. So what we have is the ability to go outside that boundary and create new kinds of tires. We have a lot of patents on this, 150. We have a lot of other business segments, but these are global to protect our technology. We made it a drop-in ingredient. There's actually 2 types. One is basically in rubber, which is this one. Another in oil, which is for some other applications. Whole idea is the manufacturing guys don't have to do much, just put it in their existing process. So the DOE gave us $1.5 million or so to develop the technology for EV tires. We actually had Goodyear make them. They made their own formulation. They're elated. We're a little not so happy. We wanted more emphasis on properties. They had a slightly different agenda, but in any case, they have a stage gate process. They're in now stage 4, which means they're going to take and optimize the formula for their uses. They won't talk to us anymore, but bottom line is they're going ahead to make tires using this product. We also, by the way, have Bridgestone going. They didn't get part of this funding, but they're also looking. So we have 3 or 4 different tire makers, but the 2 big ones, at least US, are Bridgestone and Goodyear. So you say, well, why do you do this? Part of it is if we can improve the lifetime 30%, which in the lab we can do, you can also reduce the amount of heat buildup or hysteresis and get better energy efficiency by about 10%, which translates to fleet operators like PepsiCo's 2 cents a mile. And if you're interested in sustainability, if you use 10% less energy and you use the fleet, you're talking about saving millions of tons of CO2 emission, less energy, and so on. If we look at the 20% market share, which would be Goodyear, it's $230 million. They're looking at not only this market, but Europe's. So you can see it's a large market. The other markets we started on as part of this venture are high-value parts like blowout preventers for oil well, off-road, big mining tires, truck bus tires. And again, you can see we're only talking about 1% of the market, very large markets. We're currently selling into the markets for parts, starting to sell into off the road, and our problem is getting capacity. So the team has been around for a while. Don't want to say it quite that way, but I worked for Dow for 37 years, Clive 25. So we've been in this game for quite a while. Augie's our lead guy in this business. Our facilities, including manufacturing, are in Austin. We'll want to build market development plants here, but the big plants that are thousands of tons, you wouldn't build in Austin. We'll go up and hopefully build by our manufacturing guys for carbon nanotubes. We're looking for an $8.5 million investment. Half of it goes to equipment, one for one product line, one for another, and then several million to keep operating. Once we get our capacity of 300 tons, we actually make good money. We make 50% gross margin. Let's call it, and we're selling this stuff for, call it $100 to $500 a kilo, which is $500,000 a ton. So you get all your zeros back. If we go and charge ahead, which we look every indication, we would build our first 2,000 ton plant, and that would be revenue of $80 million. That would be funded by either debt or going out and selling more of the company. So that's what we have going, and we appreciate your time. Glad to answer any questions.
Great. Opening the floor to questions. If anybody has, ideally raise your hand if you have. I see Tom does have a question.
Oops, I forgot to take my hand down.
Okay, yeah, sometimes happens. So anybody else has a question, just raise your hand on the Zoom or just pop in if you can't figure that out. Lena?
Hey, Kurt, thanks for the presentation. I guess just trying to get a little bit of better sense of exactly how it's working and why is it that EV tires are burning out faster? And then what is it that you all are doing that changes things so much? Just trying to get a better sense of how it's working here. Thanks.
I love talking technology, so I'll try to keep it short. The tires are wearing out because of the weight. With the batteries, it's much heavier car than gasoline-powered battery car. Someplace, depending on the car, 500 to 800 pounds. They're also very low to the ground, all which tears up tires. And what we do is suppress cracking. So those little individual tubes, we call it molecular rebar. It's like rebar in concrete. And you reinforce only at the molecular level. Molecular rebar is the name of the product. So you're dramatically suppressing, you do a lot of other things, but you're dramatically suppressing micro cracking you can't even see. And if the stuff doesn't wear off, you get better mileage.
Thank you.
Ron?
How's it going? Just a quick question, Kurt. Are you looking to develop your own brand of tire and then put it into the marketplace? Or are you looking to provide the product to the Goodyear, so the Bridgestones, and that's kind of the objective with that relationship? Even though they're running forward, you kind of want to catch up with the manufacturing.
I'd say I would be out of my mind if I wanted to make tires. So we're an additive that would go into their current mix. They put in about 12, 13 different things. What we would do is substitute for either some of the polymer with our tubes in it, about 20% in EV's case, or they put oil in other formulations, and we have an oil product which is 50-50. So we would sell, and what we really want to do is spin this company off and have it as a freestanding company, and we would own a piece of the equity. That's our business model.
Great. We have another question from Tom.
Yes. What I wanted to find out is, I saw those returns in terms of 2 cents per mile. That seems like a pretty good rate of return on a tire. What is the incremental cost if this product was used? How much more would it actually cost at the end of the day as part of the total cost of the tire? I mean, it seems like it's a relatively minor incremental cost for that kind of return on a tire for fuel savings.
Yes, sir. You actually win two ways. I'll skip the sustainability stuff. I'll just talk cash.
Yeah.
And typically, if you run 100,000, you're going to get 3-4 sets of tires is what you need. And you reduce one set of tires, at least, sometimes two, depending on formulation. And then to your point on the energy, you do save a lot. That's why we want to go with fleet guys. And these guys like PepsiCo or FedEx, they watch their cost per mile really well. And so consumer Goodyear will sell to anybody. That's their business. But what we did all our finances on based on selling to guys. And we actually built a chain from the supplier of the tubes to the rubber maker to us to the tire guy. And then Lucid's interested in testing. PepsiCo's interested in testing. But you make a lot of money. A consumer isn't going to keep track of that, except, of course, they don't wear out their tires. The other thing is you get 10% more mileage. You have 10% less times you have to charge.
Right.
And so it's a very lucrative deal. And we have all the math, by the way. So
I'm looking, yeah, I'm just looking at the number of tires we go through at the Air Force around the world. And, you know, all those between our air mobility commands and fighter commands, we go through tires. So it is something to look at, and I find it interesting. I mean, I'm in more installation side, but the mobility commands might be interested in some of this sort of technology.
well, the other thing is we have one customer who's a retreader, and right now he can't get nearly the price of a brand new tire because it doesn't last so long. Mixing it and just changing the tread out, and I know the Air Force does that on what airplanes and things like that. We don't know how to talk to the military, to be honest.
It's a challenge.
Yeah, we have some stories, and then we had a group of people who knew they could do it. Their brother was four-star general in charge of the Air Force, and they gave up. Now they're doing something else, which is fantastic. And we just said, oh well, eventually somebody will figure it out over there. But yes, it would be great. It helps out on regular tires too, but the real impact is on EVs because of that. Tear it up quicker, and you get 3 times the efficiency because you don't have you don't have a transmission and all that, right?
Right. Well, thank you. That's a good input. I'll keep that in mind. Well, thank you very much.
Sure. Anytime you can figure out how to have us talk to them, would be delighted. The Goodyear supplies a lot of tires to these guys, so maybe we can get the military group to get off there. You know what?
Perfect.
Lana.
Will this material help with the recyclability of tires? Because right now they're extremely hard to recycle.
Actually, we think pretty neutral. We have to go through all of this discussion with every tire guy, the safety and all that. But on recycle, it's carbon. So when you recycle your carbon, it's just a form of carbon. And it actually, we got thinking about it. It probably would help the next set of tires, but we're not going to advertise that. That's until you demonstrate it. But if you take the carbon and pyrolyze it, it's just another piece of carbon, right?
Okay, thank you.
And last question, Tom.
Hi, I'm assuming there's something special about your carbon nanotubes that a tire manufacturer couldn't just buy it from another supplier, or you have IP that protects this use case.
Yeah, we do some things that are interesting. We have a lot of IP, and everybody knows you can't use it in tires because they use the original bundles. A Type 10 micron bundle, which is much smaller than one of your hairs, has 6 million individual tubes in it. Their bundles are not very useful in tires because they're too big and they dust like hell. So what we did is the individual tubes are 1,000 times smaller, and they don't dust, and they don't have any tox properties.
Great. Well, thank you so much for your pitch. That's all the time we have. But please leave your contact info in the chat if you haven't already, so people can reach out to you, and know where they can reach you.
Okay,
With that,
I'll do
we
it.
will. Sure, thanks. And with that, we'll move on to our final pitch of the day with GDI. We have Rob here to present. So whenever you're ready, please share your screen.
Can you hear me loud and clear?
Yeah.
Okay, great. Awesome. Thanks for the opportunity. Really appreciate everybody's time today, being the last one up. Hopefully, I'll bring some energy here to finish strong. I'm going to share my screen really quick and looking forward to your questions at the end. My name is Rob Ansey. I'm the CEO and founder of GDI. We are working on 100% silicon anodes for lithium-ion batteries for a multitude of different purposes. And just to be clear, we don't want to make batteries. We want to make that battery better. We want to be the anode that goes into a variety of different cells for a variety of different applications to make it better. Just the normal disclaimer. Battery market itself is going to be over $1 trillion market by 2035. And according to McKinsey, just the components, which are the anode, cathode, electrolyte, separator, are going to be over 250 billion in Europe and North America as we try to onshore supply chains, as we try to secure supply chains. Every single automotive company, in the last 12 months have come out and said, and there was actually a really good article about it yesterday, that silicon is coming to the front as the key anode material for all of these. Solid state is still, unfortunately, many years away based on experts' analysis. But silicon is in the forefront today. It is in electric vehicles today. And one of the things that most consumers are saying is, look, if I'm going to switch from gas to electric, I can't have this range anxiety. I can't have this charge anxiety. And silicon is the only material that enables you to have vehicles with 500 to 600 miles of range that can also charge 250 to 300 miles in 15 minutes repeatedly for the life of the vehicle. And that's why all of them are saying, we want silicon, we want as much as we can, and preferably we would like to have 900 to 1,000 watt hours per liter so that you can get 500 or plus miles into any vehicle's size. So that's what we do. You replace the graphite anode completely with 100% silicon anode. We deliver it silicon coated directly on foil, and we're agnostic to the rest of the cells. So you can use LFP, you can use NMC, you can use NCA, etc. But you get a 30% boost because of the weight savings on the anode and the space saving of the anode. You get 30% more energy density. You get 3 times faster charging, hundreds of times. You have higher safety because you have a lower surface area anode. You have a very secure supply chain. So all the materials we get are from US or Europe or Japan. And we have a very strong IP position with over 20. Actually, this is already out of date. We just got another patent and we're up to 24 patents. Now, startups come out with a lot of hype and a lot of stories. So we want to have third-party validation to verify everything I just said is accurate. And who's better to do third-party verification than the Nobel Prize winner Stan Whittingham, professor at University of Binghamton? He said publicly that this is the best anode that he has tested or seen. He ran it against lithium metal. He ran it against commercial graphite. And we got better energy density than lithium metal and much, much faster charging than both lithium metal and graphite. So everything I'm saying today, we can third-party validate. The other thing startups really struggle with is scale up. You come out with some new advanced technology, and then you spend the next 5, 10 years trying to figure out how to manufacture it. We're doing that upside down. We are leveraging existing supply chains and existing manufacturing. So we use commodity gases that are available at metric tons today. We use commodity high tensile strength copper foil that we can get millions of square meters from Schlink, who is our partner in Germany. And we are using Asahi Glass Company, headquartered in Tokyo, Japan, and globally the second largest glass company in the world, to develop the equipment that does these coatings. So what does that look like when you put it all together? It looks like this. So the top right is the silicon coated foil. The bottom right is after hundreds of cycles, demonstrating that it's not delaminating, tearing, peeling, or foiling. And that's a cross-sectional SEM to show how we get it done. First, you have a high tensile strength copper foil with 3 times the tensile strength of current battery foil. We put a chemical adhesion layer directly on that so that when you put it into this industrial manufacturing to deposit the silicon, it forms a chemical bond, not a polymer bond. So no more polymer, no more graphite, no more conductor carbon. It is literally just pure silicon and copper, which means it's much easier to recycle and has much higher ionic conductivity for fast charging. And now you dramatically simplify the manufacturing process. You don't need a multi-billion-dollar powder factory and then a multi-million-dollar mixing, coating, drying, calendaring, slitting. Literally, you replace all that with existing foil production facilities, and you can modify glass coating equipment. And that's why I show a picture of the Shard in London. That entire skyscraper was coated by this plasma deposition. So when I say it can scale, it already coats skyscrapers. And now you get rid of all those other manufacturing process steps in your anode manufacturing. We're going to start with defense and aerospace because that's where they pay a nice price premium and they don't need large volumes. Then we will continue to improve cycle life and performance to get into power tools, e-bikes, consumer electronics by 28. And we already have a signed joint development agreement with one of Europe's leading EV joint venture cell companies with an 18-month JDA to develop a 1,000 watt-hour per liter battery. But we can go into any cell factory, right? This is going to be agnostic. So you're going to basically get a silicon coated copper that goes directly to any cell factory. That increases the energy by 30%, lowers formation time, overhead, lowers the cost of production. And now battery packs can either be the same size and have 30% more energy, or can actually be smaller and lighter and have the same amount of energy, and finally be able to fast charge every single cycle and increase safety. Don't take my word for it. We've already sent anode to Navitas in Michigan, CRG in Dayton in Ohio, Citadec in Spain. We've sent anode to 3 different automotive companies. And in every single occasion, they took out the graphite anode, put in the silicon anode, and immediately they're getting best-in-class energy density. So with Citadec in Spain, they made a 6.5 amp hour cell that hit just about 300 watt hours per kilogram and 900 watt hours per liter, which is just shy of that critical automotive goal to have, a 500 to 600 mile vehicle. So well on our way to hitting these advanced automotive goals that they want to hit by 2030. What's the factory going to look like? Completely different. Like I said, no more powder factory. It's literally just stainless steel reactors with foil running through them where they can deposit them. And the best part is we don't need to build a factory. We're literally going to lease space from AGC in their existing factories where they just act as a landlord, EPC, equipment builder, and co-manufacturer with us to dramatically de-risk the manufacturing and scale up, and once again lower the CapEx significantly. So what are we doing? We're raising 10 to 15 million as Series A1. We've already soft circled about half of that with existing investors and some new investors. We're looking for potential lead or co-lead or follow-on. We're going to use that money to build those first manufacturing lines. And the best part is we have matching funding. The US government this year has already given us 4 million in contracts and grants. And we also signed a financing agreement with the European Investment Bank where they will match 5 million euros for phase 1, 7 million euros for phase 2, and 8 million euros for phase 3. That will get us all the way to 500 megawatts hours of production over the next 4 years. Build out the team, continue to increase performance, and find more partners and customers as we go. Thank you so much for your time and looking forward to your questions.
Great presentation. Thanks. And opening the floor to questions. So last presentation, last opportunity to ask questions. If anybody.
Hey, Rob, can I ask you a quick question?
Yeah.
Great to meet you. I think one of our members met you at Houston at the Rice event, and they mentioned the great things about GDI. Just wondering, like, what would be like the ideal collaboration with OEMs, and could you tell us a little bit more about like how you're working with the European company, right?
Yeah.
The battery company, like what that JDA like looks like, and how can OEMs like Honda can work with you?
Great question. So like I said, we do not want to be a battery company. We don't want to be a cell company. We want to enable OEMs to make their own top of the line cells. So the way I see the market fragmenting is that the low cost cells are going to be dominated by CATL and BYD. That's going to be your LFP low range cells. They're going to dominate. The middle of the range cells that are in today's, Honda and other car companies are made by Panasonic, Samsung, LG, but they only get you about 300 to at the most 400 in the state-of-the-art vehicles. If you really want to push it to the 500-600 miles, I really want to work directly with OEMs to make their own high-end batteries, just like Honda is famous for making its own top-of-the-line internal combustion engines. And that's the way I look at the market is got to work with the end user to help them vertically integrate and make the best cells to have the best vehicles. So what we're really looking for is cell development agreements to work together to take your state-of-the-art electrolytes and your state-of-the-art cathodes and your state-of-the-art cell development integrate our anode into that by working together closely. And that's exactly what the JDA is. I can't tell you who it is because it's confidential, but they're bringing the electrolyte and the cathode and the cell design, and we are working with them over 18 months to optimize our anode and for them to optimize their components so that at the end of the 18 months, we have a really, really good pre-A sample. And if that goes well, then we'll go to a continuation to do A, B, C, and D, and then eventually work with the OEMs to scale up this technology with AGC. And obviously, Honda knows AGC really well. I assume a lot of their windshields come from AGC. So work with AGC to build these factories of the future to supply to you in 2030. Now, we're not crazy. We know it takes time and a lot of hard work, so I'm not telling you this is ready tomorrow. My guess is this will be ready similar to the timeline I mapped out in the 2030 timeframe because of how long it takes to optimize and scale up new battery technologies. Any other questions?
I'll reach out to you separately to your
Sure.
email, but thank you.
Sounds great. Awesome.
We got another question from Thomas Bloom.
Hey, Thomas, how you doing, man? You're muted, by the way. It's good to see you, though. I think you're muted in the app, so it's at the bottom left corner there.
Yeah, which was not visible. So, one, it's great to see you again, and I followed the company for years. This is really, really exciting. I just want to make sure I understand. So, you believe yours is better than what Sila and Nanograph and a few other companies have got?
Yeah, so
is there a layman's way to describe? I mean, one is obviously at 100%, you're going all the way, and there's no graphite. So what else?
That's it. You did it. So basically, none of these other companies can get more than 80% of the graphite out, because once you go above 20-30% silicon, you literally get past the point of failure with the binder system. You'll literally rip foil, you'll delaminate. Look, Group 14's material is amazing. That's why they raise so much money and they're worth so much money. But even Molly, who just announced a state-of-the-art cell with them that they were working together for 6 years at Strasbourg at the AABC, announced that they could only get to 14% silicon. And I actually asked the CTO of Molly in front of the whole room, what do you think the limit is for silicon powder in a cell design? He goes, probably 20-30%. And I'm like, that's what I thought. So, ultimately, all these other silicons will require you to continue to use anywhere from 60 to 80% graphite, which limits your gravimetric and volumetric energy, mainly your volumetric. So they're still getting some very good gravimetric numbers around 270, 280, 290, but they're really limiting volumetric. That state-of-the-art Moly cell is only 730. QuantumScape, who is a $1 billion company who spent $1 billion, they just hit 800. And it took them 10 years to hit 800. We hit 800 with 3 different companies just by sending them anode. Every single
and
one.
Swelling, have you solved around the swelling?
We allow it. So we have a motto at the company: don't fight physics, don't fight chemistry. Physics and chemistry always win. So what we said is, let's make a silicon structure that can breathe, let it do what it wants to do instead of fighting it. And that silicon layer literally breathes, but it's thinner than the human hair. So when it breathes, when it goes from 10 microns to 20 microns, it doesn't damage the separator or the foil or the tabs or the cell. It stays underneath 10% cell expansion. So and look, this isn't just a theory. Like I said, CRG, Navitas, Citatec have all made 20-layer cells, 5, 6, 7 amp hour cells without any external compression, using commercial electrolyte, and they've all been able to hit over 800 watt hours per liter. Now, there's always a catch, and the catch is the higher you go in energy, you sacrifice cycle life. So high energy cells will never have the cycle life that a graphite or a graphite composite will have. But if you can get a 600-mile car and you want 180 miles of warranty, that's 300 cycles. If you want 240,000 miles of warranty, that's 400 cycles. So there's always a trade-off between energy and cycle life. So this will be specifically for long-range cars, premium cars, that sort of thing.
And did you mention the fundraiser you're doing? This is exciting.
Yeah. Thank you. I appreciate it, Tom. Yeah, so we're raising 10 to 15. Our existing investors want at least 5 to 6 of that. So we are looking for either leads, co-leads, or follow-on. We have a complete data room. We're already really close to getting our first term sheet from one of our earlier investors, but we'd love to get more. So love to have a catch-up call with you, Tom, and see if CVG wants a piece of this.
Thanks.
All right. I think Brian had to step away. Looks like I'm in charge. Good thing it's the end.
Sure.
So, um, so if there are no other questions for Rob, I want to thank all of the companies that pitched today. Thank you so much. Super interesting, amazing stuff. Thanks to all the panelists for your terrific questions. Thanks to all the participants for staying to the very end and watching. I'll leave the meeting open for a little bit longer if you want to check the chat, finish up getting other folks' email. But if not, thank you and have a great day.
Thank you so much for putting on the event. Really appreciate it. Thank you.
Thank you.
Bye-bye.
There we go. Thanks for the help, guys.
Bye, Kurt.
Hello.
Hey.
Hey. All right. So I guess